says, so problem number 1 we don't have to do. Problem number 2 we don't have to do. And problem number 3 says create a histogram of the winning percent for every Rocky season. Okay? So that's all we have to do is just create that. So the percent of each win. So we're going to go down to W's. And then it's always good to study a data set and look for unusual features that may make the data misleading. Look at 94, 95. Is there something unusual about that? Okay. So that's the one that has 1-4 at the top. So we are looking for their winning percentage. Okay. So I wasn't given a whole lot of direction on it, and if we made an error, it's okay. So which one of those pieces of information up there is the winning percentage? The W is the win, not the winning percentage. Okay, so we have to look at the PCT. Okay, so we can plug in 0.420, 0.407, 0.457, or we could go through on Desmos and figure out, we don't have to plug in the decimal, we could just plug in the whole number, but then you just kind of make note that you had done that. So I know I'm kind of in front of people, but I can't see this that far. The old eyes aren't working how they used to. All right, so Desmos, everyone know how to find it? Okay, first thing on Desmos to plug in data is what? Yeah, we got to find the table. So you hit the plus button and find yourself the table. All right, so should we do decimal or whole number? 0.420 or 420? He said 420.
Does it matter?
Nope. Just as long as you keep it consistent. So I won't do the decimal. I'll just do for the 407, 457, 395. It'd be better if I turn towards it so I can actually see it when I'm doing it rather than 451. Oops, made a mistake already. 395. Is that me? 395, 451, 512, 568, 457, 552. Will someone read that? Keep reading it for me. I got 469. What's next? 414. 420 again. 457. 451. 451. 6. 506. 444. 475. 512. 512 again. 535. 453. And 414. Okay, cool. So we have our data. So this data that we plugged in on the board, we know that it's a decimal. If you drill in and make it a true percent, you would move the decimal 2 places to the right. So 414 is 41.4% win percentage. Okay. All right. So then, do I stay on the table when I do histogram, or do I go someplace else?
You go hit the 2.
Yeah, we head down to here, and we can either find histogram or we can type it. Let's see if I can spell today. Histogram. If it goes from slanted to upright, I did it right. And we want x1. You don't have to do x sub 1. You just do x1. And then comma. Maybe we'll make it 2. I don't know if that's going to work or not. So that's our data now, and I only made them a width of 2 wide. Is that a good histogram? Why not?
Because there's more than time. It's not right.
Yeah. More than 10.
Not touching.
It's hard to look at. So we're talking about some pretty big numbers here. So maybe let's try 25.
That's better.
And then we hit that plus button. 1, 2, 3, 4, 5, 6, 7, 8. 8 cells, that's good enough. Okay, I was helping somebody yesterday that had made a 29 width. I think that works as well. But let's see if we can clean it up. Because remember, we're not cheating the system if we can make it more visually appealing for our reader. So maybe we'll change it to 26, see what that does. I don't know, maybe 27, maybe 28, maybe 29, maybe 30. I don't know. Any one of these looks like they might. Oh, no, not 331. 31. 32. Nope, not 332. 33. 34. 35. 36. Oh, I kind of like that one. It looks like you're flipping somebody off. All right. And let's see, if it's 37, make it any better? Nope, I kind of like that 36. That looks like it actually has some symmetry to it. Have I changed the data at all? No, I am just taking a different look. And if I can create a histogram that has, 5, 6, 7, 8, 9, or 10 cells, we've done it right. And this, in fact, has 6 cells. It doesn't mean 10 cells is not better than 6 cells. Again, you are giving the picture for your audience to be able to look at. So I think this has a much better message. And it's not that this one's wrong, but let's go back to 30. I mean, that's what 30 looks like versus 36. Okay? We see more of a fluid pattern to it. So I think we could stick with that one. And that's visually appealing for your reader to look at and say, oh, look, there appears to be a pattern. We have followed all the rules for a histogram at this point. All the cells have the same width to them. We don't have any gaps in it. Sometimes a histogram might have gaps, and that's okay. But we are following to the rules. We have 5, 6, 7, 8, 9, or 10 cells, and it totally works. And again, 5 cells is not any more or less correct than 10 cells. Okay? Again, you're trying to get your reader to capture their attention to say, okay, maybe I will read the article. Okay, maybe I will read the publication. Okay, now what's something that the histogram won't help us with? If we just had the histogram, what do I lose?
Exact like numbers.
Yeah, the data itself. Yeah. So the histogram just tells me I happen to have so many things. So if you were to look at this big cell here between 450 and 475, I guess, or 450 and 480, I guess it is. We know that we have 9 games that somewhere amongst that number was the percent they won. Okay. Now, if you made this done with decimals, you're not going to be in the 400 range. You're going to be in the 0.400 range. Okay. If you made them as true percents, you would be in the 40% to 50% range, things like that. Okay. So that's basically all you would have had to have done for the third problem. Now, they asked us for number 5, look at the data for 94 and 95. 1994, 1994, and 1995. So it goes from 0.453, so 45.3%, to 1995, 53.5%. So they did better in the 95 season than they did in the 94 season. So if I were to look at those two pieces of thing, so in the 94 season, we're at 453, so we're in this region. Okay, we're in the tall region. And if we look at the 95 season, we are in the 53. Okay, so these are 30 apart, so it might be somewhere in here. I don't know if that's 510, 520, 530. So we're in this region. So one season I'm in this bar, one season I'm in this bar. Okay, is there a discrepancy? And there's not a right or wrong answer in this situation. I mean, if I fall on this block, this is where most of our games had fallen as far as our percentage of wins. If I fall on this block, I have a far lesser percent. So it's more likely that the Rockies will continue to score in this region, except this season they might be down here. But I'm in two different cells. Now, you can change that data table a little bit. You can change your histogram to maybe where it starts making them look closer together. But again, your first order when you're dealing with a histogram is you want the histogram to be appealing for the person who is reading your article to catch their attention. Okay? We're all human. We look at pictures first. Okay? Here's a big article. Oh, great. I hope they are like a severed foot in one of the pictures. Oh, I'm going to look at the severed foot. Okay? I mean, that's just the long and the short of it. So are there questions about how to do those problems? And again, like 1, 2, and 4, you didn't even have to do, because 1, 2, and 4 would have been if you were using the graphing calculator. But I think Desmos is a lot more user-friendly. If I had changed my histogram to this red one, if I change my histogram to this one, this is an appropriate histogram to look at. If I looked at the 94 season, 453 is in this tall one, and then 535 is probably over, let's see, we're going by 30s. It might be actually in a further cell over this way. Okay, so then there are a couple cells apart. But again, it becomes one of those things like, do we take faith in what we're looking at? I mean, if we were to start doing these observations of data, we could actually, further into this class, figure out the probability that the Rockies will have a certain percent winning season based on our data. Now, other things that are hard. Friends, this is raw data. Raw data are not randomly selected pieces of information. When I say randomly selected, if you went through and you were to count, you figure out a random selection to do. But this is just data itself. Unfortunately, too often they will say, oh, this is our data, therefore this event has to take place, like they can tell the future. I mean, it's a tool, but it's not an exact science tool. So let's not stress too much about that. Okay, so we are going to be on 1.5. Let's see where is 1.5.
113.
Let me say like this.
A lesson, yeah.
Oh, it's not page 113.
Page 11? Okay.
Yeah, don't listen to me, my bad.
We still love you.
Never will listen.
Okay, stem plots and dot plots. Okay, stem plots and dot plots. They are basically the same. Okay, they're just a different way of doing numbers. It's a way to think about a histogram. Okay, so if we talk about a stem plot first, sometimes they call it a stem and leaf. And so what you do is you would collect your data. So if I were to look at this stem plot where I have 3, 4, 4, 5, this means my data is 34, 34, 35. If I look at the 40, there's nothing in the 40 range, so we just leave it as a placeholder, but there's no data there. And then my score would be 52, and then 61, 61, 62, 65, 65, 65, 65, 65. And it keeps going. And then you have so nothing in the 11s, 12s, 13s, or 14s, but then you have a score of 150. Okay, and this looks like its final sale price. So the stem is to the left of the vertical line and includes the first digit in the final of the price, and leaves are to the right. Vertical contain only the final digit. Okay, so how many final sales prices are represented here? So you can just count it. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. There's 24 pieces of data up here. So I counted the numbers to the right to figure out which data I had up here. What's my lowest sale price? My lowest sale price is a 34. My highest sale price is a 150. Okay? that make sense? Kind of how I just kind of perused through that for you? Okay. So again, these are things that allow us to look at data. When we look at data, we start maybe getting to, an idea of, I might be seeing a pattern taking place. Do I know a pattern's taking place? I've made observations. Well, those are things that you would test. And then after you do that, then you would take a random sample and try and create a term called the normal distribution, but we're not there yet. Okay. So stem and leaf is different than a histogram, though it looks like a histogram, but sideways, but using numbers. But you do indeed maintain the whole data set. Like you can tell by looking at stem and leaf what is all your data up there. Okay. The histogram doesn't do that. The histogram is a range, or in the x direction, like how wide it is, how many times something happened in those events. And then stem plots are a good choice when you have a small enough amount of data. And a stem plot looks uh-oh.
Who's Stirrup Christopher R?
I don't know. He's some
Actually,
village.
wait, what's the R stand for?
Reuben.
Reuben?
Robert.
Robert? Okay.
I'm psyched.
I thought you would be a Richard.
Nope.
You're Richard type.
I'm not a Richard.
Chris, Rich, Stirrup.
Christopher Robert Stirrup.
I was right about Robert.
You guys want to know my youngest daughter? We call her May, but her full first name is Mabel.
Mabel Stirrup.
Mabel Stirrup. Oh, yeah, we did that. No, I'm just kidding. Her real first name is just May. M-A-E. But it's fun to say. We should have called her Mabel. I had a buddy of mine. His last name was Caps. His first name was Hubert. He went by Hub, so Hub Caps.
Is that true?
Yeah.
Okay. You can't trust it.
I mean, let's face it. If your name was Hubert, wouldn't you go by Hub instead?
Somewhere out there, there's a name, Richard Scrooge.
Yeah. Hub.
Hubba.
Hub Caps. All right. So step plot show each of the outcomes, and then you come across something called a dot plot. A dot plot looks a lot like a stem and leaf, but stem and leaf, when you're looking at it, it's just data points. It's kind of vertical. It somewhat looks like a histogram. A lot of times a dot plot, you are talking about discrete data, meaning you had to pick your pencil up to make each dot, so it's not a continuous piece of data. Okay? So if we went here, it says, what does each dot represent? Well, it represents the fuel economy. So it looks like we have a car that gets 16 miles per gallon, 23, 24, 27, 29, 31, or 30, 30, a bunch of 31s, a bunch of 32s, and a 40 out there on the outside. Okay, so again, it's a representation of data. They're relatively easy to use. You just put the dots, you collect the data. And again, this is
I bet that's a Chevy Volt. Like a Prius,
Prius.
maybe.
My car gets pretty good gas mileage, being I got to plug it in every
What do you
night.
drive?
I got the Nissan Leaf with the larger battery pack and motor that they put into their Aria.
Mm.
And so I have this little tiny four-door car that puts out 405 horsepower.
That's kind of funny.
Yeah. And I will tell you, when I go to the digital speedometer, the governor on the car is 141. How do I know that? Because I got there and it wouldn't go any faster, and there's plenty of battery to go. But Nissan felt 141 is fast enough. 142 is too fast.
Too fast.
Huh? No. You know, when I go to pull onto a freeway and you got the two lanes that are side by side.
Yeah.
There was a Corvette next to me. I won. Yeah. Hey, mine's stock.
Was that I-25?
Yeah.
Yeah. Go to C470 at like 11:30 at night. There ain't no one there.
The fun thing is you can't hear me. I just go. It's silent. Wait for the turbo. How many ponies are you pushing? Too much?
On like my base lap too, at like 650 wheels, my kill maps at like 900 wheels.
Uh-huh.
Just flowing the whole.
I don't know what that.
Yeah, mine's 0 to 60 in 4.6 seconds, so it's pretty fast.
I don't know.
And of course, my wife got really mad at me because at 20,000 miles, I had to have new tires put on. So a dot plot. Hey, I gotta have some fun in life. Of course, when I drive the car with my wife in it, you're driving too fast. Yeah, but you see that gap between those two cars in that lane? Yeah, watch this. I'm there. So I have some fun.
What's your favorite car you've had?
Oh, I had a 1986 Camaro,
Oh, that's pretty awesome.
and
Like an
it,
IRC or what?
yeah, it actually when I first bought it, it had the six banger in it.
Oh, yeah.
But one of my good friends named Mark Vine, his dad just bought a ZR1 Corvette,
Oh.
and a big windstorm came through, and a tree landed on his car, so it was totaled. And so for $500, we took the motor, the ZR1 motor, transmission, and rear end, and put it in my car.
That's pretty awesome.
Oh, it was over 500 horses. I will just say that car, I had it my first year. I was teaching in Vegas, and there was one time I was driving to school, and somebody who thought they had something in their car wanted to dance, and I won, and I pull in right in, so we had a road similar to Union, but you could park on the road in front of our school, and I always pulled in front of the school to park. So I go and pull in front of the school to park, and here's all the buses. So kids are getting off the buses, and I got red and blues behind me. Oops. Yeah, he didn't give me a ticket though. He looked at me and he's like, ran my stuff, and he's like, "You teacher?" I'm like, "Yeah." And of course, I see my principal standing at the stop of the steps like this. And he goes, "That won't happen again, will it?" And I'm like, "No, I'll outrun the cop next time." So, yeah, that was a fun car. Yeah, but it had a pretty good rear end on it. I mean, huh? It was posi. So it held the. You didn't have one wheel that would spin more than the other. Both would spin with the equal force. Yeah, okay. I didn't know that term. We knew it was posi traction. So I will tell you that car didn't do good in the rain, did good in the snow. But on dry pavement, woo, baby. All right. So I have on our front board a representation of a dot plot, which is absolutely useless data because it's just made up. So basically, if you went and looked at your data points, you'd say, I have a 10, I have a 10, I have 11, I have a 12, I have a 12, I have a 12, so on and so forth. And that's basically how you would go through. What would the minimum of the one over on the board be?
Or 16, yeah.
Yeah, 16 and the maximum is 40. And then how many observations? You just count it down. So 16 dots, so 1, 2, 3, 4, 16. So so it's like stem plots, dot plots require a smaller number of observations, but they do indeed maintain the entire data set. So, friends, stem plots, dot plots, maintain data set. Histograms don't maintain the data set. Okay? Got that? Make sense? All right. Anything else that we can destroy for you guys today?
Not a car.
Okay, so we talked about charts and circle graphs and histograms, stem plots, dot plots. Hey, so a pie chart, circle graph. What should it never be?
3D.
3D. 3D is really dirty math. It's dirty statistics. Don't do it. Okay? Call out people who are doing it, saying, dude, you're doing it wrong. You shouldn't do that. You're trying to impact your reader. You're trying to influence your reader too much.
Okay, it's dirty. Don't do it. Okay, there are a lot of statisticians who, as soon as they see one small discrepancy in some sort of chart, they just toss the entire report and will not accept it, no matter how good the report could be and how good the statistics. Just making something incorrectly just because you think, oh, look, Excel will do this and we're going to make it look pretty. Don't do it. It is a big no-no. Okay, it's not accepted. And I gotta say that, like, statisticians out in the world, statisticians are not the people, like, if you show up to a social gathering, you're like, oh, let's go talk to, Philip over there, who's a statistician. That's not the conversation you want. Okay? They get a little boring. They are a little boring, but they make fun of it. All right. All right, so my friends, will you take a look at your homework for tonight? It's going to be 1-5. 1-5, the front and the back. You have the rest of the period to work on. Do you want to go get one of the books? Yeah, my books are store. It's blue. That's it. Just take a picture. You need someone to go with you. Just.
Mr. Strip?
Yeah.
Can I say that 150 is something that stands out?
Yes. Yes.
I don't get the.
So it's funny because when you work at my shifter, you can see the vertical level. I mean, you saw most of where it was going. You kind of look this way, or if you pass through it this way, you can see the road.
Look higher.
I mean, Windows 6 Live.
That's what I'm telling him.
I've done 4 workouts in the last 24 hours. I'm gonna do another one later today.
What workouts?
I biked for about an hour yesterday from home and to lunch. I did swimming yesterday and weight training. I did swimming this morning. So I did 3 hours and a half of swimming, weight training, and an hour. I had the weight training again today.
So you have stupid life.
I'm gonna go golf
I
tonight.
slowed down.
You're doing what?
I hate golf. I could see it.
I would eat the balls.
45.
Not my phone.
And
Call my club.
people live next to me, in front of the highway, gets next to me.
My name is Cole.
I'm telling Leo.
I am just a girl.
Passenger princess, I am the stick shift. That'd be so funny though. I've seen it. You've seen it happen. I'll put it on my phone.
The best song I think.
Okay, but only if you listen to
Yes.
Okay.
only if you listen to this whole album.
Whole album.
It's only an hour long.
Whole song. Okay, how about this? I'll give you one song, and you give me one song. I'll listen to it, but I'll only if you listen to mine. I'm not gonna do the whole album. We'll each do one song. How about that? I'll sing you.
What's it called?
I would take one of my workers.
You get okay. The make of each car parked at a shopping mall. Ford, Toyota, and General Motors. You tell me there's no London. Yours is not
You won't like Satan's.
Yeah.
You know, so I'll screenshot this and then I'll.
Oh, no, this one, you had, your shit was like, you can see like fingers, like first, second, third,
Oh,
fourth.
yeah, Gator. This is literally the top one. I'm a lawyer. I thought Gator over here was one. This is what? Oh. It won't. I screenshotted it. And I'll search it up when I have data.
And the gas pedal got lodged floors underneath, so he's reached down trying to pull it off the floorboard rather than throw it in neutral. Like, that's a deep through that light. That's a deep right by that. You just everybody. Well, I wouldn't even look at it. I know, your head popped up after you.
I'm so good at that.
Yeah.
I'm confused on stem plots.
You what?
I'm confused on stem plots.
Okay.